ago. Components of sand, clay, gravel, weathered and finally hard rock make up these layers. Testing indicated that between 33 and 40 metres underground was a hard rock type that the bridge structure could rely on. Bunya phyllite is one of the hardest rock types known, with a compressive strength of 5 to 50 megapascals, and would provide a stable solid base for the bridge. Before permanent construction on the main bridge could begin, temporary works were required to establish an effective working platform at the river's edge. A 60-metre long temporary jetty was built on the south side, off which a 100-tonne crane and piling rig attachment completed river piling. Due to the inferior quality of the north side riverbank, a specifically modified floating barge was used as a temporary working platform. Bridge piling on both the south and north sides was done using piles driven 35 metres into the riverbed using an attached 7-tonne drop hammer. Each pile needed to be driven down a minimum of 50 centimetres into the hard rock and filled with 100 cubic metres of concrete to ensure stability. Once piling was complete, preparation for the pile cap would begin. The pile caps, known as precast elements, were constructed off-site at a precast yard at Hemet. The size and shape of the pile cap was determined by the need to comply with Maritime Safety Queensland's ship impact guidelines and to minimise tidal flow resistance. On the 11th of November 2008, the largest available barge in Australia docked at site, carrying with it 9 precast elements, weighing 650 tonnes in total. Transported up the river from the Hemet precast yard, the journey took 4 hours along the Brisbane River and past the CBD.
The pile cap elements were manufactured in Hemet, came up on the barge. Before the pile cap units actually arrived, we had a lot of work to do with the temporary structure to support the pile cap units. So that temporary structure was all fabricated from structural steel and it was installed on the piles themselves. Fortunately, the levels that we had to work with were below the high water mark, so we could only work in a very short period every day when we had the low tides. This only gave us about 2 to 4 hours a day where we could work. As a consequence of that, it took us about a month to set up all the structural steel work, complete all the welding of the frames, and have the site basically set up ready to accept the precast boats when they arrived on the barge. So the barge had a 200-tonne crane on it. We lifted each of the precast elements from the barge onto the structural steel frame, and as the units came in, they were connected to each other and basically sealed up to form a watertight, what we call a precast boat. So it was basically an upside-down bath which formed the pile cap shell. It took us about 2